Okay, so in section 3.4 we're looking at properties of logarithms. There's tons of properties of logarithms, and you've seen them all before. Here they all are right here. The biggies are the product rule. When you have multiplication inside a logarithm, you add two logs. The quotient rule is if you have division inside a logarithm, you subtract the logs. And then the power rule, if you have a logarithm to an exponent, then that exponent just moves out into the front. So what we're going to do is we're going to prove these guys. And to prove it, we're going to look at the log base b of rs is equal to log base br plus log base bs. And how we're going to prove that is we're going to let x equal log base br, and we're going to let y equal log base bs. Okay, and so when you look at these things then as exponentials, you're going to have b to the x equals r, and b to the y equals s. Okay, so that's what you're looking at. So if I do r times s, that's going to be equal to b to the x, b to the y. And remember that if the bases are the same, you add the exponents. So that's going to be x plus y. Okay. And so if that's true, then when we rewrite this as a logarithm, then what we're going to do is we're going to look and see that we're going to have this guy right here inside the log, and we're going to have it equal to this guy, and here's my base. So I'm going to have the log of rs base b is equal to x plus y. And oh, by the way, x plus y is, the y part is right here, the s, and the x part is right here, the r. And so what you end up with is log base br plus log base bs. So now we're going to use those properties that we just saw, and we want to expand out the log of 8xy to the fourth. Well, it's all multiplication. So when we expand this log out, we're going to have log 8 plus log x plus log y to the fourth. And then 8 is actually 2 to the third power, so this is log of 2 to the third plus log x plus, and then there's my 4 as an exponent, so he moves into the front, 4 log y. And then my very, very last step is just going to take that 3 on that first guy and put him in front. So it's going to be 3 log 2 plus log x plus 4 log y. And that's all you've got to do on that guy. There's nothing else to it. Okay. Expanding the bottom one with the natural log, so you're going to have a natural log in your answer the whole way through. The easiest way to think of this guy, though, is to think of it in kind of not with that square root, but as x squared plus 5 to the 1/2 power over x. And immediately what you should realize is we've got division. So this is going to be the natural log of x squared plus 5 to the 1/2 minus the natural log of x. And then to finish that problem off, the power just moves into the front, so it's 1/2 the natural log of x squared plus 5 minus the natural log of x, and you're done. We've expanded that logarithm. Okay, now instead of expanding, we're going to condense this logarithm all into one, and you'll notice right off the bat that we've got a minus sign in there and a 2 in front. So let's go ahead and deal with this 2 right here. He's going to move up inside that log. So I've got natural log of x to the 5th minus natural log of xy squared. So that's where that guy is. And then we have division, and it's top minus bottom, so it's going to be the natural log of x to the 5th divided by xy squared. And go ahead and distribute the squared on that denominator, so that's natural log of x to the 5th over x squared y squared. And then to go ahead and simplify that problem one more step, you're going to have the natural log of x cubed over y squared. And that guy's done. And you need to show all of these steps. And if you'll just go one at a time, you'll see the things that need to reduce until you finally, you just can't reduce this guy. But notice right here, x to the fifth and x squared, you can reduce that. And that's where the x cubed comes from. So the change of base formula, it's actually really handy, even though a lot of calculators these days give you the option to put in whatever log and base that you need. The change of base formula is handy. You can use it any time on any calculator that has a log button. And the change of base formula is over here in between the red arrows. Here's your change of base formula right here. And so basically what we're going to say with that change of base formula is whatever is inside the log, in this case it's a 7, we're going to take the log of that on top, and then the base is 4, we're going to take the log of that on bottom. So the change of base formula on this particular problem is going to look like this. A log of 7 over a log of 4. And you just punch that into your calculator, and when you do that, you end up with 1.4037. And logarithms grow so slowly that you will want to list off several decimal places in order to get the right answer. So once you follow that change of base formula right here, then you're going to get your decimal right down here. And so that's what those arrows represent. And you can use any calculator to do this, and you can use any base. An equality statement for this would be, we could also use the natural log. So we could say the natural log of 7 divided by the natural log of 4, and hey, guess what? It also is going to be 1.4037. And so we can solve these bottom problems out the same way. On the log base 3 of 16, we can go the natural log of 16 over the natural log of 3. That'll be no problem. Or we can do the common log of 10 over the common log of 6. Or if we wanted to go like super crazy, if you've got a fancy calculator, log base 3 of 2 over log base 3 of a half. All of those will give you the correct answers for each of these logarithms. So if you can't do that last one with the calculator that you're on, that's okay. You can just use a natural log or a common log. But on that first guy, log 16 divided by log 3 is 2.5237. So 2.5237. Log 10 divided by log 6 is 1.2851. And then that last guy, log base 3, 2 divided by log base 3 of 1/2 is -1. So that's all there is to it. These guys aren't bad, but it's super handy to be able to know how this change of base formula works. Okay, and lastly is understanding how these graphs relate back to the natural log function. And even though it's given to you in a different base, the change of base formula allows us to look at what's going on. So if we look at g of x here, when we've got g of x, we would rewrite this as the natural log of x divided by the natural log of 5, which is the same thing as 1 over the natural log of 5 times the natural log of x. So what are we doing to the base function? That's the question. And the answer is we're just multiplying by a constant. Like if you plug 1 divided by the natural log of 5 into your calculator, you'll get a decimal. And in fact, you'll get a decimal that's less than 0. And so when I punch that in, 1 divided by natural log of 5, I get 0.6213 natural log x. Well, what is this number? What is he doing right here? He's giving our graph a vertical shrink. So by a factor of a natural log of 1 over a natural log of 5. So this guy's going to be a vertical shrink by a factor of 1 over the natural log of 5. Okay, look over here at the other guy, natural log, or the log of 1/4, base 1/4 of x. Same thing. We're going to look at the natural log of x divided by the natural log of 0.25, which is the same thing as 1 over the natural log of 0.25 times natural log of x. And so, this is what we're looking at. Well, 1 divided by natural log of 0.25 is negative 0.7213 times the natural log of x. And so this is also going to give us a vertical shrink. And not only is it going to give us a vertical shrink, this negative sign in the front right here gives us a reflection over x. So even if we have these logarithms in different bases, we can compare them to a natural log graph and know exactly what's being done.